Hello friends, Shivansh this side, and today we are going to discuss mechanism of one again very interesting reaction. This plus NaNH2 gives terminal alkyne. And let me tell you just for reference, this question was asked in G 2015. Sorry, J 2005 as a question of chemical equilibrium along with it. Like write the mechanism of this reaction and chemical equilibrium. Like my purpose of making video is not this. My purpose is that this reaction is really very interesting and I find its mechanism really very interesting. That's why. See, so H and now NH2 minus. So first of all, like just a prereq, let me prove that NH2 minus is very strong conjugate H plus acceptor base. So stability of conjugate base is directly proportional to strength of acid, conjugate acid, like strength of original acid, and vice versa. Stability of conjugate acid is directly proportional to strength of base. So like we can say a very strong base. So like NH2 minus plus H plus gives NH3. So NH3 is its conjugate acid. Now stability of conjugate acid is directly proportional to basic strength, and NH3 is very stable. That's why NH2 minus is very strong base. One more logic is that like this reaction, backward of this reaction is very tough because NH3 is a base, right? It's Bronsted acid as well, the Bronsted acid which can give H plus, but more than it's Lewis base and a good Lewis base, so it wouldn't be very plausible reaction. So it's like forward reaction would be very much plausible. So here we prove that. Now back to the reaction. Here H plus NH2 minus takes H from here, C minus. Okay, let's move this H plus NH3. Okay, like we are considering NH2 minus an axis, NH2 minus still there, NH3 gone. Now this comes down, this comes here, like to maintain the bonds here, so maintain valency here. So this is formed. Now like next part of this reaction would be really tough, but we can see that this carbanion is not as such very stable because R is electron releasing group. R is actually her alkyl group, so alkyl group is releasing electron, and again due to which it is very weak carbanion, carbon ion. So NH3, like it's not very lethal step, but let's assume it would break into H plus. Like we can also say that it took H plus from its previous neighbor. Like reaction is not like 1 2 3 and all gets converted, one gets converted then पीछे वाला आता है. Okay, then H goes here, like we can say. So we get a diene, and it was really a JE's question, like J question, J 2005. There was something about chemical equilibrium of this the same, but the first part was the same, right? The mechanism of this reaction. Now this diene plus NH2 minus, we have two hydrogen here and one hydrogen here. Now it has option that which hydrogen should be taken. Now like we know that strength of organic acid is directly proportional to electron withdrawing group. Okay, like I don't mean that. Like if H goes from here, the Carbanian formed wouldn't be very stable. Okay, ignore what I said before. Okay, wouldn't be very stable. Like I am correct. It's inverse to ERG, electron releasing group. The reason is the same. If we make Carbanian here, it would be very unstable. So why would it give its H? I told you before. Stability of conjugate base is directly proportional to stability strength of acid. So that means this acid is not stable, but this is like far away from ERG, and there is electron like sp2 carbon over here, which is pretty electronegative, so H minus would work. NH2 take its minus, and we get RC double bond C minus. This goes here, this goes here. RC triple, okay, RCC triple. I think I have added extra carbon. No, it's all right, I guess. Minus, oh sorry, minus gone, and minus over here, and again ERG. So not like, no, not dipole moment. ERG, electron releasing group, so electron density here is crowded, so NH3 has to break to make it like, okay, so H plus from NH3, or we can even like we have put NaNH2, so it might also be such that we make like, we take this compound out and we can do some other reactions. But that is it for the reaction. RCH, RC triple bond C plus NH2 minus NaNH2 gives RC C triple bond C, and it's really very interesting reaction. I like it very much. And yes, along with it, so thanks for watching the video. I hope you would have liked it. Please like this video and subscribe my channel, and please share this video. Thank you.